In question number 30, it says, a truck on a straight road starts from rest and accelerates at 2 meters per second squared until it reaches a speed of 20 meters per second. Then the truck travels for 20 seconds at a constant speed until the brakes are applied, stopping the truck in a uniform manner in an additional 5 seconds. There's the concept right there. The word uniform means constant. Okay, and we're given the fact that acceleration has occurred in this problem, but we're also given the fact that the truck travels at a constant speed for part of this as well. This is a segmented motion problem that actually carries two concepts. The first concept would be constant acceleration. It has a constant acceleration to it simply because of the fact that the truck will speed up and slow down at a uniform rate. But it also carries with it a constant speed concept as well. And with constant speed, there are fewer formulas. In other words, there's just distance, velocity, and time. Okay, fewer variables and only one equation. Okay, now I'm going to use x instead of d just to keep it consistent with the variables used in constant acceleration. Since this is a segmented motion problem, I would highly recommend charting out the problem. Okay, I'm going to break this down into 3 segments. Segment 1 is the speeding up. Now, in the speeding up part, we know that this is a constant acceleration. And by the way, I abbreviate things all the time. Okay, the abbreviation I used for constant acceleration is CA. Now, when we have a constant acceleration concept, our job immediately is to list the 6 variables apply and try to identify as many as you can, up to 4 of those 6 variables. The 6 variables will always be listed as x, x naught, v, v naught, a, and t. Now we go back and we reread the first part of this problem. It tells us a truck starts on a straight road from rest. Anytime you see the phrase from rest, starts from rest, that indicates that the starting velocity, the initial velocity, is 0. And accelerates at 2 meters per second squared. Anytime you see the unit of meters per second squared, that goes along with acceleration. Until it reaches a speed of 20 meters per second. We know the final speed is 20 meters per second. We're assuming the initial position to be 0, and we don't know how far we went nor how long it took to get there. Now, the second part of this motion is constant speed. Now, this part's a lot easier simply because there's fewer variables involved. I'm going to call this x1. This becomes x2. And I don't really know how long it's applied. We just know that x2, and I have v2, and I have t2. I just know that the truck travels for 20 seconds at a constant speed. But what is that constant speed? It doesn't say. But wait a minute, if you remember, the speed increased to 20 meters per second. Therefore, when the truck gets to 20 meters per second, they are traveling consistently at 20 meters per second for this time interval of 20 seconds. I do not know how far we're going though. And lastly, the third segment is slowing down. Negative constant acceleration. Slowing down would be negative constant acceleration. List the variables, same 6 variables. X, this time it would be x3, x naught, v, naught, A, and T. Well, what do we know about that third time segment? It says stopping the truck. Well, that's a big clue right there. Stopping the truck means the final position, or the final velocity rather, has to be 0. The initial velocity, well, the initial velocity is same as the constant velocity the truck was traveling for the 20-second time interval for part 2. We do not know the acceleration. We do know that it took 5 seconds for this motion to happen. We do not yet know this, nor we do not yet know this. Now what we need to do is we need to, having charted out this information, look now to see what the question's asking for. Part A, how long is the truck in motion? Now, to answer part A, we need total time. That would be T1 plus T2 plus T3. So this would be T1, 20 seconds is T2, and 5 seconds is T3. So we already know part of this answer already. I'm going to leave a blank to come back to that. Plus 20 plus 5. Right? We're 2/3 of the way done. So now I'm looking at this right here. I need a constant acceleration formula that has time in it, because that's what we have to solve for. In addition, it has a change in velocity and acceleration. Now, looking up here, looking at these variables I have, the one that matches it the best is this first equation here that has v naught, a, and t, in which case v equals v naught minus at is the appropriate equation we can use. So let's start with that. V equals v naught plus at. We would subtract v naught both sides, and v minus v naught equals at. Divide by a, and time equals v, which is 20 minus 0, over a, which was 2 meters per second squared. Meaning it takes 10 seconds to speed up to 20 meters per second. So 10 plus 20 plus 5 is a total of 35 seconds for this trip. Part B, well, Part B is asking for what is the average velocity of the truck for the described motion. Well, the average velocity is total displacement over total time. Now, the total time, that's easy. It's 35 seconds. We just figured that out. The total displacement would be adding up your individual displacements. Okay? So instead of separating them as x and x naught, what we can do is we can just chalk this up to delta x. We can find a delta x1, knowing that x naught is 0. A delta x2, and again, a delta x3. And then by doing so, we're going to assume x naught equals 0, and we don't account for it in the problem. Okay, here's the way we can begin the first segment. I'm looking for a formula that has delta x in it, okay, a change in velocity, and now time. We know time is 10 seconds for the first interval of speeding up. Well, I could use this equation here. That has a change in position, delta x, initial velocity, which in this case is 0, acceleration, and time. I could easily use that formula. I could also easily use this formula here. The point is, when you have more information in your list of variables, you get to choose more than one formula to solve the problem. I'm going to choose the fourth one to solve this particular one. Delta x, 1, equals v plus v naught over 2 times t, which is, if you remember, v naught was 0, v is 20 over 2 times 10. Now 20 over 2 is 10 times 10 means delta x2, or delta x1 rather, is 100 meters. Okay, so we have 100 meters for the first segment. The second segment, v times t, and that's 20 meters per second times 20 seconds, and that's 400 meters. Plus, now in the third segment, we're looking for delta x3. I could use the exact same formula. Delta x3 would be equal to v plus v naught over 2 times t. In this case, the final speed is 0. And I have 20 over 2 times 5. Well, 20 over 2 times 5 comes out to 50 meters. So putting all this in, we have 100 plus 400 plus 50 is 550. Divide that by 35 seconds, and we're looking at an average velocity of about 15.7 meters per second.